Hi children, so let us discuss the example problem here. Example number 3.4, it's on page number 48. We started discussing it. So the first part of the question is to find out the height through which the ball rises when it is thrown from a 25-meter high building. So it is given in the problem that the height of the building is 25 meter and the person standing there can be considered as a point object is throwing a ball upward. So when the ball is thrown upward, the acceleration due to gravity is always downward. So we can consider, and it is given in the question, g is equal to 10 meter per second square. As acceleration is a vector quantity, we need to find out the direction or assign a direction to it. As the acceleration is always directed along the force acting, and here the only force acting which can be considered is the force of gravity. So we can write, and which is directed towards the center of the earth, which is in the downward direction. If you consider the upward direction as positive and the downward direction as negative, then you will get g is equal to minus 10 meter per second square. And the ball is imparted a negative velocity, or it is given an initial velocity v0 is equal to 20 meter per second. Okay, so we know the initial velocity of the ball, which is 20 meter per second, acceleration due to gravity g. You are to find out the distance through which it rises when it rises to the maximum distance. So in this case, when it rises to a maximum distance, it reaches there, stops momentarily. So you can consider during the course of its journey, if its initial velocity is 20 meter per second, it will reduce and finally reach 0. So v is equal to 0. So we can utilize this equation in order to an equation of kinematics. We can utilize this data in order to find out the distance over which it rises. We have an equation that relates the initial velocity, final velocity, acceleration due to gravity, and the distance traveled at v square is equal to v0 square plus 2ay. Okay, here I have given y because the motion is along the y direction. So how can you substitute v square? It is 0 square, v0 square, it is 20 square plus 2 into ga is minus 10 meter per second square into y. On solving, we will get 400 plus or minus 20y is equal to 0, and you can take 20y to the other side and solve for y, as you will get 400 divided by 20, which is equal to 20 meter. So we got y as 20 meter, that is the distance through which the ball rises, as 20 meter. Now to find out the second part of the solution, second part of the question, it is asked that how long will the ball be till it reaches or touches the ground. That is, you have to find the total time of journey of this ball once it is being projected from the top of the building to a particular till it reaches a particular height and then falls back to the ground. What is the total journey of the ball? So in this case, let us find out. We can actually solve it in two ways, where you can find the time taken for the first part of the journey and then for the second part of the journey and add them, t1 and t2, and finally find the total time taken. Okay, but actually we go for the second or the alternate method, where we exploit the idea of displacement. That is, in order to find out the displacement, we need to know only the initial position and final position. So let us consider the initial position of the ball to be on the top of the building, and let us consider that as the origin. Now as the ball, and finally it reaches here. So what is the displacement travel? It can go through any path, but we know that final minus initial will give you the displacement of the object. So you can have the equation y minus y0 is equal to v0t plus half at square, isn't it? We have an equation like this, where y is the final position, y0 is its initial position, and v0 is its initial velocity, and a is the acceleration due to gravity in this case, and t square, t is the time taken. So let us see, in this case the initial position we have considered as the origin. So let us take the initial position y0 to be 0, and the final position, or the y minus y0 itself, can be considered as minus 25. Why minus 25? Because as it is displacement, it is directed down. It is in an opposite direction. So you can have y minus y0 as the total displacement for the whole journey, and minus 25, which is equal to v0t. V0t is 20t plus half at square, half into what is a, that is minus 10 into t square. So we have 20t minus 5t square, and you can take this minus 25 to the other side, it will become plus 25 is equal to 0. So we can just rearrange this as 5t square minus 20t minus 25 is equal to 0, isn't it? 5t square minus 20t minus 25 is equal to 0. So this is the quadratic equation in t, and we can solve for this, and you will get t is equal to, it is actually, you can simplify it again by dividing throughout by 5. So it is t square minus 4t minus 5 is equal to 0. So the product is minus 5 and the sum is minus 4. So you can think of the case when it is minus 5 into plus 1. Okay, so the solutions are t is equal to, or we have t minus 5 into t plus 1 is equal to 0. So that gives t is equal to 5 seconds or minus 1 second. But we cannot have a negative value for time. So what we'll do, we can skip the second part and we'll take the time, total time taken for this journey as 5 seconds. So I hope you have understood this kind of solution. This is much easier, where you assign the proper direction should be assigned in that case, and you have to you can use a single equation in order to find out. So we don't have to consider the, if you are going for the other solution, what you have to do first, you have to find out the time for this journey. In that case, initial velocity is v0 is 20 meter per second, but final velocity is 0. You'll get some value for that. Okay, maybe 2 seconds. Then after that, for the second part of the journey, you have initial velocity v0 is equal to 0. And you can use it in the other equation v0t plus half at square. In that you can solve for the time if you know the total distance traveled. So in this case the total distance traveled is 45 meters. So if you can assign the correct direction for the displacement, then you will get this equation, and the correct direction for the acceleration and all, you can get this using this equation. So that is whichever is easier for you, you can follow. Okay. Next is, let us find out. So next let us see the topic free fall. What do you mean by free fall? You have an idea about free fall or freely falling objects. See, when you consider any object or anything that is being dropped from a particular height, or that which is being thrown upward, what is the force acting on the body is only the gravitational force of earth, or it is the force of gravity. You can consider it as when certain other things are neglected, that is the case of air resistance and the variation of acceleration due to gravity with height, depth and all. If you neglect those factors, we can consider this object, any object that is released near the surface of the earth, it moves under the influence of gravity. So what happens is, we know that this body will be continuously pulled towards the center of the earth, and due to which the body either retards. When it is thrown upward, the force is acting downward. So it either it retards in that case, and when it is released from a particular height, or after it reaches a particular height, it falls back with increasing velocity. In that case, it accelerates. In both the cases, what we have to consider is the acceleration due to gravity is constant. Okay, and the value of acceleration due to gravity is 9.8 meter per second square, and if you assign a direction for this acceleration, it is negative. The reason why we assign a negative value for acceleration due to gravity is that the force is always directed towards the center of the earth, and the acceleration is always along the direction of the force. So it is negative 9.8 meter per second square. And we have considered another thing, that we have assumed this to be a constant. Actually, there will be slight variation with several other factors, such as acceleration due to gravity can depend on several other factors. For the time being, in this case, we are considering it to be a constant. Another thing we are neglecting is the air resistance. We consider we neglect the case of air resistance or the frictional force of air to neglect in this case. So what happens in free fall or a freely falling object? For a freely falling object, we can consider the free fall as that it is a motion of any object that is released near the surface of the earth such that it moves under the influence of gravity alone. Okay, so that is actually what free fall is. So in this, we have to study the relation between velocity and time, acceleration and time, position and time for a freely falling object. So we have neglected air resistance because certain cases, when you consider the case when you drop two objects from a particular height, we know that as it is expected both the objects should land at the same time, but that doesn't happen. We see that a coin or a heavy ball lands takes little time than a paper or a feather which is dropped at the same at a particular height, at the same height from the same instant. So the reason for this is actually the case of air resistance, which we have deliberately neglected in here. And another thing is when a particular thing is dropped from a particular height, it reaches a terminal velocity. That is also due to the frictional force of air. So these two things we have disregarded, and we will be discussing those things later when we discuss frictional forces and properties of fluids. We'll be discussing terminal velocity as well as frictional force. Okay, so for the time being, let us see the case of free fall. So free fall for any object, let us write an equation for the free fall based on the equations of kinematics. So we have the equation V is equal to V0 plus AT. So in the case of free fall, you can consider when you consider a body being released from a particular height, the initial velocity can be considered as 0. And for a freely falling object, A is minus g, isn't it? So according to that, what is the relation between velocity and time? So V is equal to minus gt. And time can never be negative, so we have to shift this negative sign to the left hand side. It will be minus V is equal to G into T. Now this expression shows that V is directly related to time, or minus V is directly proportional. It's a linear equation. If you look for the power, this is the independent variable and this is the dependent variable. So power of T is 1, so we can write minus V proportional to T. So we got a relation between V and T, so we can easily plot a velocity time graph. Now, in which quadrant will you plot this velocity time graph? This we can see the y coordinate, because the motion is happening in the y direction, the y coordinate is negative. And velocity has to be plotted in the negative y direction, and time can never be negative, so it will be positive. So it is plotted along the positive x-axis. So let us take that as the fourth quadrant. So in this, the x-axis is positive, y-axis is negative, and this is time, and this is velocity. Velocity is in the negative direction. Okay. Now what will be the shape of the graph? As it is a linear equation, as I told you, y is equal to mx plus t is the equation for straight line, isn't it? Y is equal to mx plus t is the straight line, is an equation for a straight line. In this case, the y-intercept is 0 because we have minus v is equal to gt. Okay, and minus y is equal to mx. That's all we have got. Okay, and m is the slope of the graph, which is the acceleration due to gravity in this case. See, minus g. That is the negative slope which we have in the graph. So when you try to plot a graph, you will get a straight line starting from the origin. So this is the shape of the graph, and if you take the slope, you will get the acceleration due to gravity, which will always be a constant, as it is a case of uniform acceleration, uniformly accelerated motion. So the case of free fall is a case of one-dimensional motion where or you can consider the body is under uniform acceleration, where the acceleration is considered as the acceleration due to gravity. So that is how free fall is related to rectilinear motion. Okay. Now minus v proportional to t. So this is the shape of the graph. Okay. Now next let us find out a relation between, or a graph between the position and the time, or let us try to plot a graph which is the position time graph. Okay, for that we have to use this equation, which is the equation y is equal to v0t plus half at square. So we require this equation v0t plus half at square. So in this y coordinate, it is also in the negative y direction, and a is equal to minus g. So what do we have? Y is equal to, what about v0? V0 is 0. Initially, if you are dropping from a particular height, the initial velocity is considered to be 0. Y is equal to half minus half gt square by putting a is equal to minus g. Now again we can shift the negative sign to the left hand side. So it will be minus y is equal to half gt square. Here half is a constant, g is also a constant. So let us find out a proportionality relation between the displacement as well as the time. So it will be minus y proportional to t square. What would be the shape of this such a graph? Actually these graphs are non-linear. They are not linear and they assume the shape of a curve. So let us try to plot, again plotting this in the fourth quadrant, because y happens in the position time graph. So change in position should be taken along the y axis and change in time should be taken along the x axis, positive x axis. So as this is the negative or y dash axis, you can have, this is the origin, the shape of the graph will be something like this. It will be a non-linear graph because y is proportional to t square. So look for the power. If it is a cubic relation, or if it is a squared relation of the independent variable, then you have a shape of the graph to be non-linear, or it will be a curve in this case. So the position time graph of a freely falling object will be in this manner, y proportional to minus y proportional to t square. So these are the two important graphs you need to consider. Actually position time graph has been taken away from your syllabus, but in free fall we can consider that. Okay. Now if you try to plot an AT graph, that is an acceleration time graph for the same case, what it would be? That is very easy because we don't have acceleration to be depending on time. Isn't it? Because we have a to be the acceleration due to gravity, which is a constant in this case, which is a constant which is known as which has a magnitude. It is minus 9.8 meter per second square. So it is very simple. If you plot an AT graph, a is negative, so again we will consider it in the negative y axis, along the negative y axis, and this is the x axis and it is the time axis. What will you have? It is a constant value. Suppose this value corresponds to 9.8 meter per second square. If this time is plotted in seconds, then you will have a straight line parallel to the x-axis. Okay, so this is the acceleration time graph. So these are the three important graphs we need to know under free fall. Now there can be a misconception related to free fall. You may think that any object that is released near the surface of the earth can be considered as free fall. No, it is not like that. It is actually any body that is thrown upward. Once it is released, if it moves under the influence of the gravitational force, can be considered as a condition of free fall. That is any ball or any object that is thrown upward or released from a particular height. Both are freely falling objects. So as I told you, we have neglected the case of air resistance. There is a very popular experiment where you can, if you have, you can watch it in YouTube, where a heavy ball and a feather both are dropped from a particular height in a vacuum chamber, and you can see that the displacement of this body is exactly same at each second or each time interval, and both lands at the at the same time. Usually when you drop a feather and a ball, you know that ball reaches the ground first, or a heavy object reaches the ground first. But in that experiment, when the conditions for air resistance has been removed, that is when this experiment is done under the conditions of vacuum, when no air is present, that shows how these two objects the mass of the object does not depend on that time taken, time for travel. So in this equation you cannot see, because both are accelerated equally by the force of earth. It is only the air resistance which shows this difference. So you can go for it and watch it also. Next is stopping distance. Stopping distance is another important factor in road safety and all. Actually, when you are driving a vehicle, you might have seen in the case of when you are given road safety instructions and all, you have to keep a safe distance between any two vehicles, isn't it? The reason for that is when once an vehicle is going to stop, or when you apply the brakes, it retards uniformly. That is, the velocity reduces uniformly as per the acceleration or the deceleration of the vehicle. And we know that it doesn't come to an abrupt stop. It further actually moves a certain distance and then comes to a stop. And this particular distance, an object or a vehicle or anything that moves, once it starts steadily retarding, is known as the stopping distance. So this actually decides so many things on road safety, because it actually decides the factors on which accidents and all happen. Because if you don't follow that safe distance, then a vehicle in front applies a brake, all of a sudden what happens, somebody behind can come and hit the vehicle or bump into the vehicle which is actually in the ahead of you. So that and it also depends on the reaction time of the human beings. Normal human beings, the reaction time is 0.2 seconds. That is, a person requires certain time, even if it is a fraction of a second. He or she requires a certain time to act to a situation, and all this depends upon the road safety features and all. So let us find out an equation for the stopping distance. From the equation, v square is equal to v0 square plus 2ax. X is the distance moved along the particular direction. Suppose as we told that, as I have told you that when a body or when a vehicle suddenly slows down, it must be having an initial velocity. So this is the initial velocity. And what about the final velocity? It comes to a stop. So final velocity can be considered as 0. So we have v0 square, 0 is equal to v0 square plus 2a into x. Now what is this? Is the distance through which the body moves before it comes to a halt, isn't it? So we have x is equal to minus v0 square divided by 2a. So this is the expression for the stopping distance of a vehicle, which shows that it is directly proportional to the initial velocity of the vehicle. So as soon as you have, that is, every time you might have experienced that when the body is moving with a very large velocity, or when it is momentum is very large, it actually depends upon the momentum also, because we have very heavy trailers and all, the distance, the safe distance to be kept in front of a trailer and all, it is very large, because it depends upon the momentum also. So you can see the distance is the stopping distance is directly related to its initial velocity. So higher the initial velocity, larger will be the stopping distance, or and for a constant retardation. A is the retardation of the uniform acceleration, or the acceleration with which the body comes to a stop. Okay, and it depends upon the vehicle. So this is the expression for the stopping distance. So you can see that it is proportional to the square of the initial velocity. So that is why you have to, there is always a safe speed for you to drive along highways, and also that is safe speed because it is directly proportional to the square of the initial velocity, and the impact can even be more worse when the speed is very, very large, and the chances of collisions with other objects or other vehicles is also more when the initial speed is, or initial velocity of the body is large. So this is the expression for stopping distance. Now the relative velocity in one dimension is not there in your syllabus. We have almost covered all the topics under this chapter. Relative velocity is not assigned in your curriculum, and the notes have already been provided. Then what we need to discuss are the problems. Graphs are important. How to draw a graph can be very important in this chapter.